A city can spend billions on roads, drainage systems, and smart infrastructure, but sometimes one failed manhole cover is enough to stop everything. Because beneath every city, there's an invisible network working constantly to keep urban life moving. Modern cities depend on underground drainage systems to transport stormwater and wastewater safely. And throughout this hidden network are access points called manholes. Simple in appearance, but critically important. These covers must survive. Heavy traffic flooding, heat chemicals, continuous vibration, and years of environmental exposure. Traditional manhole covers usually use either cast iron or reinforced concrete. But cast iron has a problem. In sewer environments, gases react with moisture and form corrosive acids. Over time, corrosion weakens the structure. And because cast iron has scrap value, theft becomes a serious infrastructure problem. Concrete covers face a different issue. They're brittle. Repeated loading creates cracks, water enters, and structural failure begins. So engineers started looking for a different material. One that could be strong, lightweight, corrosion-resistant, and durable.
Dudhi FRP is a composite material made using glass fibers for strength, resin for bonding, and engineered additives for performance. Instead of relying on mass alone, Dudhi FRP uses engineered material behavior.
One common manufacturing process is called SMC, compression molding. A premixed composite sheet is placed inside a heated mold. High pressure compresses the material. The resin cures, and a high-strength engineered structure is formed. This controlled manufacturing process improves consistency, structural integrity, and dimensional accuracy. Because they are lightweight, installation becomes easier. Because they don't rust, service life improves. Because they have almost no scrap value, theft is drastically reduced. And during flooding conditions, structural stability becomes extremely important. Not every manhole cover is designed for the same load. Engineering standards classify covers based on load-bearing capacity. For example, a 15 for pedestrians, B125 for parking areas, D400 for highways, F900 for aircraft pavements. Using the wrong load class can lead to catastrophic failure. Interestingly, many manhole cover failures are not caused by poor products. They happen because of incorrect installation, poor support, uneven load distribution, or improper load selection. In infrastructure engineering, installation is just as important as design. As cities become denser and infrastructure demands increase, materials must evolve too. Modern infrastructure requires longer service life, lower maintenance, better sustainability, and improved life cycle performance. Most people never think about manhole covers until they fail. But for engineers designing the cities of the future, small infrastructure details can make all the difference.